After today's lesson, you will be able to identify absolute value functions given a table of values and identify the rate of change for an absolute value function given a table of values. For each of these tables, we're going to describe the rate of change. We're going to identify the type of function, circle the vertex if applicable, and make a quick sketch of the function just in the blank space between the graphs. Anytime we need to find the rate of change or identify the function, the first step is always to do our change in x and change in y. So please do that now. And you can see that we are given complete tables. There's no fill in the blank for this part of the lesson. So you can see here that we have a change of x that's 1 consistently throughout my table. For my y's, I'm decreasing for a while and then I'm increasing for a while. So I have -3 and then +3. And what I like to do when I see that change, that is what indicates to me that I have an absolute value function. And I like to go right between where it changes from decreasing to increasing. And if I go between those values, that points to what our vertex is. So you'll want to circle your vertex and write down your two rates of change. You can write your rate of change of -3, 3/1, like just list it as two separate rates of change, or you can write it as the plus or minus symbol is just a addition over a subtraction symbol, plus or minus 3/1. The thing to keep in mind here is that this is still two rates of change. So since there's two rates of change, it cannot be linear. We already said that it was absolute value, so we'll write that here. And our unit rate, because this is already per 1, that is our unit rate. So again, you can write it with that plus or minus symbol, 3/1, or you can write those out individually as two separate numbers. Let's take a look at the second one. We're going to do the same thing. You are going to do the change in x and the change in y. You can see that the change in x is increasing by 2 throughout the table. The change in y starts off increasing by 6 and then decreasing by 6, which then this does show us that this is an absolute value because you have two distinct sections. Remember, we want to split that up. Wherever you see the change from increasing to decreasing, that represents our that it is going to point to our vertex, our turning point. So you can circle that in your table. That's what I want to see. And so because we're increasing where we have a +6 and then it goes to decreasing, what that looks like, and we didn't do that in the last one, I'll do that here. That means your graph is going to go up and then it's going to go back down. So when I say sketch a quick sketch of your function, it's just like this. You know it's a V shape, and if it's increasing then decreasing, it's going to be going up before it's going down. Similarly on number 1, because it's decreasing first and then increasing, it's going to be a V shape going like that. Let's talk about our rate of change. You can see that I have +6/2, +6/2, and that's the same for these four values here. And then I have -6/2 as indicated here. For our unit rate, recall that our unit rate has to be something over 1. Both of these fractions, 6/2 and -6/2, can be divided by 2, goes into 6, so that would be 3/1. And -3/1. Remember, you can also write that in this shorthand way with the plus or minus symbol, 3/1. Just for unit rate has to be over 1. And of course, we talked about this because there's these two sections with the turning point with the constant rate of change. I know that this is, with two constant rates of change, I know this is absolute value. Looking at our next one, you're going to do the same thing as the previous. We always start with the change in x and change in y when we're trying to identify the function and its rate of change. Looking here, you can see that our change in x for the whole table is increasing by 1. And for my change in y, it is decreasing by 2 for the whole table. So this is not an absolute value function because there's no turning point. There's no increasing to decreasing or decreasing to increasing. So since negative 2 over 1 is the same all the way down, our rate of change is the same going all the way down. And so this is a line. This is a linear function. And we know that it is decreasing the whole time. So I'm just going to at the top. So our graph is going to look something like this. It's just going to be going down in some way, and that's enough for the sketch. We know that it is a decreasing line graph. For our rate of change, we just have 1. We know that it is negative 2 over 1. Because it's already over 1, that is the same as my unit rate. And of course, because it was constant, we know this is a linear function, and we should write that this is constant. To quickly summarize this lesson, rate of change remains the same. It's change in y over change in x. Unit rate is always something over 1. This got a little messed up in the formatting. That should look like it's the change in y over change in x. You divide that on your calculator, and then that is over 1 for the unit rate. This is especially helpful if you have something that comes out fractional or a decimal. And then the key things that we learned in this unit, all absolute value functions have a turning point, which is called a vertex, and that divides our table into 2 sections that have constant opposite rates of change, a positive and a negative. And an example of opposites would be 2 and negative 2, or negative 1/4 and positive 1/4. And your page should look similar to mine in your notes.